All right, so we're going to look at the area of triangles, and I think you start learning the area of triangles in like 6th grade. I could be wrong because I don't know much about what goes on. I just know it's down there somewhere. But basically, you've known how to find the area of a triangle for a long, long time. So we're going to start out by looking at the formula that we have known for a long time for the area of a triangle. That is 1/2 base times height. Hopefully that is not something you feel like you need a formula chart for anymore. But let's talk about the base and the height of a triangle, just as a little reminder that every triangle has 3 sides, hence the name triangle. And here, since this is where I have the height drawn in perpendicularly, then this has to be the base. Now, if I wanted side BC to be the base, that's fine, but then I would have to draw the height from point A perpendicular to that side. So basically, you have 3 heights you can draw in, 3 bases you could use. You just have to use the right ones that relate to each other. Make sense? Okay. So what we're going to do, if we have the base and the height, then great, we can find the area of a triangle. It's super easy. But what if I don't have the height? I can't just draw this in and assume that this is going to bisect this side, because it doesn't. And I got some of you in a little bit of trouble with those application problems because you were drawing in a height and then trying to make it bisect the bottom, and that doesn't happen unless that's an isosceles triangle. So we're going to use the trig that we know to figure out what we could do if we can't find the height. So here it says we know that the sine of C, so in this triangle, angle C is right here. And so I'm using this little right triangle, sine opposite over hypotenuse. So it is h over a. Then if I want to take that simple little equation and solve for h, I would just multiply both sides by a. So h is equal to a times the sine of c. Easy enough? Okay, so now we're going to substitute. Well, I've solved for h. And I have an h right here. So basically, I'm just going to take this and substitute it in there. So that would give me 1/2 times b times a times the sine of c. But when I write it down, I'm going to flip a and b just because we usually write things down alphabetically in formulas. So what this looks like now is area of the triangle equals 1/2 times a times b times the sine of c. And you don't have to know the height at all. So the letters we're using are relative to this particular picture. You look at number 1, there's no letters there at all, except for the units, and that doesn't really count. So it's not a matter of just, oh, it's AB sine of C. It's fine to think about it that way, and then you'd have to label a triangle like this. But what's happening here is, here's side A, here's side B, here's angle C. So that's 2 sides in the included angle. So it's a side angle side situation. So it's 1/2 times 2 sides multiplied together times the sine of that included angle. Those are the pieces that you have to have. It can't just be any random angle. So if I chose to use angle B, then I'd have to use sides A and C, right? You could use, and it doesn't matter. Like our setup would look different, but in the end, we'd get the same number for all of it. Okay? Any questions at all? Awesome. So let's look at number 1. We're going to find the area of the triangle. So area of the triangle is going to equal 1/2. So I have these 2 sides in this angle, so that's side angle side, that's good. So I have one side which is 11 times another one which is 16 times the sine of 105. And then it's just a plug and chug problem. We substituted it in. We can put it in the calculator. Now, I'm a big proponent of don't really do anything until, like, let the calculator do it all, right? And so, except for maybe the 1/2, if it's easier for you to type 0.5, that's fine, but I wouldn't try and actually take half of anything. That's where it's super easy, but it's where the ridiculous mistakes happen. So I do 0.5 times 11 times 16 times the sine of 105. And that's what I get. And since it doesn't tell me how to round, how many decimal places should I have? 3. Okay. So area of the triangle then equals 85.001. This is area, so it is feet squared. And most of the time, I'm not telling you what to round to, so you practice. If you're not told, do it to 3 decimal places, because in Delta Math, a lot of times all the time it does tell you, just so there's no confusion there, because not everybody that's using Delta Math is doing AP stuff. But even on the AP test, it could tell you the nearest 10th, nearest 100th, or whatever. But if it doesn't, then it's 3 decimal places. So you got to get used to what to do when you're told and when you're not. Okay. Any questions at all? Easy enough? All right, let's look at number 2. It says the area of a triangle is 106 inches squared. 2 of the side lengths are 25 and 21, and the included angle is acute. Find the measure of the included angle. All right, so I'm going to draw my little picture, and anytime I have an area of a picture, it's not like this is the rule or anything, but I put it on the inside just so that I know it's not a side length or whatever, but it's the area of that thing. 2 of the side lengths are 25 and 21, and I'm looking for the included angle. I'll call it theta. So still going to use area, but this time I have different set of information, right? My area is 1/2 a times b times the sine of c. So I substitute in what I know. I know the area. That's equal to 1/2 times 21 times 25 times the sine of theta. I need to get theta by itself, so I first need to get the sine of theta by itself. Those 3 things are being multiplied by sine, so I'm going to divide by that. So I'll get 106 divided by 1/2 times 21 times 25 equals the sine of theta. I don't want the sine of theta, I want theta, so what do I do? Not the reciprocal, but the inverse, yeah. Sine inverse of 106 over 1/2 times 21 times 25 equals theta. If I wanted to, go ahead and get rid of that 1/2, could I make that 106 into 53? The answer to that is no, because that's not dividing by 1/2. So another reason why we may not want to try and simplify things there. So that's theta. I'm not going to go find the decimal for that. Okay, I don't care what the decimal of that is. I'm going to go and just substitute it into my area here. So area of the triangle is equal to 1/2 times 21 times 25 times the sine of theta. Okay, so now I know what theta is. It's the sine inverse of, oh, wait a minute, what am I doing? I don't know what I'm doing. I'm working another problem. It's asking me for theta. I'm going and finding the area. I was going in circles, like some of you do, right? I know. What would I have ended up with? I would have ended up with 106, right? I was going in circles. Total brain fart there. I'm looking for theta. This is why you should always remind yourself what you're looking for. So it says, find the measure of the included angle. Boom, that's it. So when we type that into the calculator, instead of doing something ridiculous, I'm going to do sine inverse. So function sine inverse of, I already forgot because I threw myself off there. All right, 106 divided by, I'll do 0.5 times 21 times 25. Okay, that's what I'm looking for right there, instead of making stuff up. There's my answer. So then, since it doesn't ask me for theta or whatever, it says find the measure of the included angle. So I need to say measure of included angle is 23.817 degrees. Lordy, lordy. Okay. Any questions? All right, so let's look at number 3. Let's see if I can work this one correctly. I want to find the area. In order to find the area, I have to have 2 side lengths. I don't have 2 side lengths here. I only have one of them. Do I have enough information to find another side length? Yes, I do. So 76 goes with 7. 59 can go with this one right here. I'll call this x. What do I use to find x? Sine. I'm going to use the law of sines. So I'm going to have the sine of 76 over 7 equals the sine of 59 over x. So I'll solve for x, and I get x equals 7 times the sine of 59 over the sine of 76. Okay. Now here's the one. Here's where I'm not going to type that in right now. I could. Okay, I can do this a couple of different ways, but I'm just going to leave it as x right now. Okay, it's just x. I need, if I have these two sides here, those are the two side lengths I have, then I need this angle. What's that angle? Or how do I find it? Good. Add those together, subtract from 180, and I should get 45, I believe. Okay. Because remember, if I find a decimal for x, and then I type that decimal in, then I'm going to not be rounded to the correct decimal places at the end. That's what makes that bad. So then the area of the triangle that I'm looking for, it's 1/2 times 7 times x times the sine of 45. So I'm just going to take this and type that part in there in my calculator. Okay. So that'll give me, let me clear all this off. I'll have 0.5 times 7 times, then I'm going to put this in parentheses here, 7 times the sine of 59, close those parentheses, divided by the sine of 76, close those parentheses, times the sine of 45. So I got it all in there in one step, so I'm not rounding anything anywhere, and this is what I end up with. Okay. Any questions at all about calculator issues or whatever? Okay, so this will give me area of the triangle is equal to 15.304 millimeters squared. Okay. Oh, I have, yeah, that's right. These are, okay. Thought I wrote the wrong number. Any questions at all? Okie dokie. All right, then let's look at the next one. It says the area of a triangle is 25 meters squared. Two of the side lengths are 11 and 5, and the included angle is obtuse. Find the measure of the included angle. All right, so my triangle, 25 meters squared, 11 and 5. Looking for the included angle right there. So I'm still setting it up in the area formula. It's the area is equal to 1/2 times the two sides multiplied together times the sine of that included angle. Which means that I'd have 25 divided by 1/2 times 5 times 11 equals the sine of theta. Then what would I do? Take the sine inverse. And if you don't want to write out the sine inverse part, if you want to stop there as far as your work is concerned, that's fine. As long as you do it correctly, you've set it up and it's okay. So I'm going to do this a little bit differently because last period I forgot to, because I didn't write it down, I forgot to type in the sine inverse when I started typing, and then I didn't want to go back. So I'm just going to do it that same way. I'm going to do 25 divided by 0.5 times 11 times 5, right? So that's not my answer because that's what I'm supposed to take the sine inverse of. But if I already have that decimal, by the way, if you didn't know this little button right here on the Desmos calculator will put it in fraction form for you. So you can see the two differences there. So I want to take the sine inverse of that. So sine inverse, and then here, if I go back to the main, I have an answer button. So, and it even puts it in there so you can be sure that that's what you really wanted without you typing it in. And then that's what the calculator gives me right there. I get that theta equals, what, 65.380? Is that my answer? No, why not? It's not obtuse. This says the included angle is obtuse. Okay, so you remember when we're doing law of sines and we had the ambiguous case and the calculator gave us an answer and we had to figure out what it gave us the first quadrant answer every time. That's what the calculator is going to give you. We had to figure out what our second quadrant answer was because sine is also positive in the second quadrant. So that's what's happening here. The calculator is going to give you first quadrant answer no matter what. So that's a first quadrant angle. It is not obtuse, and that specifically says obtuse. So what do I do with that to get the angle I actually want? Subtract it from 180. So I need to take 180 minus theta because it says obtuse there. Then I can say that the measure of the included angle is 114.620 degrees. What questions do you have? Anything at all? Okay. All right, so number 5, we need to find the area. I can't just draw in the height to use 1/2 base times height because I wouldn't know what the height is and I don't have the information to find it. Can't use the formula in my first step because I don't have an angle, but am I capable of finding an angle? Yes. Does it matter which angle I find? It doesn't. I can find any of them, but once I find one, then that determines the sides I have to use, right? We're going to find this one just because it's probably the easiest place for you to draw theta if it's small. So if I find theta, then that means in the area formula, I'm going to use 6 and 14. If I find this angle instead, then in the area formula, I have to use 6 and 16. Does that make sense? And it doesn't matter, you get the same answer anyway. So what do I use to find theta? Cosines, good. So I'm going to have 16 squared equals 6 squared plus 14 squared minus 2 times 6 times 14 times the cosine of theta. So that would give me 16 squared minus 6 squared minus 14 squared over negative 2 times 6 times 14 equals the cosine of theta. And then, of course, I need the cosine inverse of that. Whether or not you write that down, that's totally up to you. But, again, I'm not going to type this into my calculator right now because it'll give me a decimal. And sure, you could do it, and then you could use the answer key if you can get that on whatever you're using. That's fine. But I'm just going to leave it exact for now. I'm going to find the area of my triangle. Area of the triangle equals 1/2 times 6 times 14 times the sine of theta. And theta is going to be the cosine inverse of that icky fraction. So whether you do it separate, whatever, just make sure you're not typing in rounded numbers. Okay, so I'm just going to type it in all at once. So that'll give me, so clear this off. So give me 0.5 times 6 times 14 times the sine of the cosine inverse of 16 squared minus 6 squared minus 14 squared. Close that so I can make that into a fraction. And then that'll be negative 2 times 6 times 14. I think I have everything there. And even if I don't close, it still gives me an answer. It'll close it for me. Any questions at all? If you feel like you need to write it out before you type it in, again, that's fine. But I know more of you like to skip steps than do extra steps, so I want to make sure you know what you can skip and what you can't skip, but you could always write more if you want. Just don't take forever, because then sometimes you run out of time because you're writing too much. So then I can just say that the area of the triangle equals 41.569. Okay. What questions do you have? Anything at all? All right. Now, that wasn't, I mean, you had the skills to do all of that. You could reason through that, you could figure it out, whatever. But there's another way to find the area of a triangle if you have all three sides and no angles. And is it easier? Well, that's always a matter of opinion, but we wouldn't have to go through all this cosine inverse stuff if we use Huron's formula. So Huron's formula works for side, 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 if I don't have any angles. So here's what it looks like. The area of the triangle is equal to, it's a big old long square root, be s times s minus a times s minus b times s minus c. Those are all lowercase letters, by the way. I know, especially with my bad handwriting, it's hard to tell if the s's are capital or lowercase, but a lowercase s a lot of times stands for side. It does not stand for side here. A, B, and C are the side links. S stands for something else that you most likely have never heard of before. So S is actually 1/2 of A plus B plus C. So I want you to think, if we just did A plus B plus C, basically if you just add up all the sides, what's that called? It's not a trick question, it's an easy question. The perimeter. Okay, so this is half of the perimeter. Excuse me. So this is actually called the semi-perimeter. Okay, so that's what S stands for here. It's the semi-perimeter. So it looks like a complicated formula, but it's really not that big of a deal. You find S, and then you're just going to multiply S times S minus all the other sides, and we're good to go. So it's a little bit more straightforward than the way we just did number 5, but, you know, we're going to get the same answer either way. So let's try number 6. We're going to have to find S first. It's going to be 1/2 times 18 plus 19 plus 21. So that gives me 29. So that if I'm going to use Huron's formula, that's going to give me 29 times 29 minus 18 times 29 minus 19 times 29 minus 21. So let me remind you, the majority of your mistakes come from easy, simple, stupid things, okay? So if you were trying to minimize those, then I wouldn't even actually do any subtraction. This subtraction is not difficult whatsoever. But have you ever subtracted two simple numbers and done it wrong? Yes, of course we have, because we do it fast and we have brain farts, and I was even working the wrong problem earlier. So whatever, and I actually do know what I'm doing. You may not always believe that, but I do. So I would just leave it like this. I got a calculator. I can punch buttons. I just got to make sure. Remember that the calculator is only as intelligent as the person pushing the buttons, so we still have to put it in there correctly. But I can do the square root of 29 times 29 minus 18 times 29 minus 19 times 29 minus 21. Boom. And then that's it. The calculator does it all. Makes it a plug and chug problem. Bam. I mean, nothing wrong with putting 11 and 10 and 8, but again, you don't want to do something ridiculous. Those are very, very frustrating mistakes that we are all capable of. Area of the triangle is 159.750. This is still area, so that is miles squared. Any questions at all? All right. Then I want you to do number 7 on your own, using Huron's formula. When you finish, double check yourself with me and make sure that we agree. If you have any questions or anything, please let me know. Okay, tell me what's wrong about my answer in number 7. Because none of y'all caught it. It says to the nearest tenth. I didn't read my own directions. It says nearest tenth. We even talked about unless it says otherwise. It says otherwise. So our answer is actually area of the triangle equals 173.5 inches squared. Dang it. There you go.